Let me try to get my. Remember, there's like a.
Yeah, I don't know. I am terrible with that. If I do it, I'll mess it up. I don't know if we need to. We don't have. If we need.
Isn't there like a way?
There, that's good.
It's still doing the scrolling.
Well, it's PowerPoint. That's why. This thing they don't know about, right?
I think we're doing good if it.
Yeah. Ah, shit.
Oh my God, is it one of these? Oh no, it's blank.
Okay. Yeah, it's blank, yeah.
Hang on, let me try a few more things. Every time we run into this trouble. Why is there not page up, page down button?
I do not know. The one time I tried to mess with that, I got it where I kept on having to try and.
Okay, Alt down.
All right. Oh, it works.
But you need to not be in that mode.
Oh yeah.
You need that's full
That's
page, and then what if I do this? Is it full page? Right.
Okay, it works.
I
Yeah.
got it.
Okay, let's not mess it up. Let's just.
Do we have a note well?
No, we don't have not those. But
Somebody's got to have one, right? Like,
I have one.
Alvaro's gonna yell at us. Following process.
I don't think so.
He is.
Is he here?
I don't know.
I don't know if we need the slide. I can talk. We can talk to it. I got it on my. Cheers page here.
Wait. I got a way to do this. Hang on.
Chairs page. Yeah, I got the chairs page, so I can just talk to it.
Where'd you go for that?
I went to IETF.org/about/notewell. Note with a hyphen between note and well. Yeah. We're on the chair. We're in the one from the chairs, so we're fine. Should be. The link from the chairs. Yeah, there it is. Okay. Okay, good. You can talk to that.
Thanks.
Okay, so this is the LSR working group. We're going to get started.
So
The beginning is, so if you're not supposed to, if you don't want LSR, you're in the wrong place. You can't hear.
Asseyez-vous et fermez la porte, s'il vous plaît.
What was that? Sit down and close the door. Nice. Je parle un peu français. Très un peu. So this is the note well. We managed to find one. I'm not going to read all of that, but it's important that you do. Okay. I'm sure you've read it all by now. Oh, it's so good I can't get rid of it. Not kidding.
we really wanted to go.
I can't get rid of it. There we go. Okay. You want to run stabs?
Yeah, I'll stand up and do it. So this one.
No.
No, it doesn't. Okay, so I won't.
It's the
Okay, next slide. We haven't had any RFCs. I'm going to go kind of quick to leave room for the presentations. We've gotten a note from the RFC editor, and all the segment routing drafts that we're waiting on misreferences are going to be published very soon. I was hoping it would be before this meeting, but it's not. So, well, that'll be good to get these all published. Okay. And in AD, we still have this H-bit support, the host bit support. Is Kayer in here? No. Well, anyway, trying to get the primary authors, to finish the response. There was some confusion about Alvaro's comments, and that's pending. The Yang data model for OSPF protocol. We finished the 80 comments. We've had a IETF wide working group last call. There's been some comments on a few more comments on the list, and a few more directorate reviews. We've had multiple Yang doctor reviews, and luckily the last one we didn't hit anything new, but we've had some other reviews, and there's some minor comments and things to answer before it goes to the IESG. Restart singling, that's just recently we just recently requested publication, so we're waiting AD comments. And this cross address family traffic engineering, since Alvaro is one of the primary authors, one of the co-authors, Martin, is taking on the AD review, and that has also gotten through most of the directorate reviews. We have completed working group last call on these. We have to write up the Shepherd's reports, the two. And yeah, let me say one more thing about these. So these documents, as you know, we spent a lot of time in past years, and so we got to capture that discussion in summary in the Shepherd's reports and send it to the ADs, the AD. Finally, I'll let you talk about this one.
Yeah, so we had a process, FUBAR, snafu, whatever, on the Yang model for ISIS. I think if you remember a meeting or two ago, we decided to do like OSPF first, and then get the comments, capture the comments, and make adjustments to the ISIS. But then that sort of got the signals got crossed on that. I don't know where exactly those signals got crossed. It might have been at 80 level, might have been at working group level. So the AC, thinking that we had done a working group last call on both, submitted the ISIS. But we have, process-wise, we have not actually working group last called the ISIS Yang model. So we are currently receiving AD reviews on the ISIS Yang model. For process's sake, we will be working group last calling this document as well, starting like today. So this is first notice of the working group last call on the ISIS Yang model. We'll do a note to the list, also sort of saying, hey, we got this backwards. But other than that, this has been around for a long time. I don't think that we are going to get in too much trouble for having reversed the order on this time.
Okay, we got both of these entropy label capability drafts. We revised these to advertise per prefix capability. And thanks to Peter, and I did the OSPF. I don't know if he did the ISIS too, but they're both they both reflect what, or if Stefan did one of them, I don't remember. Yeah, Stefan did one and Peter did one, and now we're ready to working group last call them. The one thing we do need are BGPLS code points, and rather than having a separate IDR draft, we've just before this meeting, I had some discussions with Ketten, and he has agreed to add that to one of these drafts. It will probably be OSPF because he works every day with Peter, and it'll be just easier to do the same. Of course, Stefan will be working with us too pretty soon. So anyway, so we should get those soon to working group last call. Next one. We're going to cover these one. Flex algorithm is going to be covered today. Same with these Yang models. And these ones are, let's see, everything's covered today. There hasn't been any activity on the ISIS routing for spline leaf topology. I'll check on that we'll check on that with the office, see where they're going. Not too much on, we need more discussion on the prefix originator, and there's been some discussion on the PCE security capability. I don't think it's not ready for working group last call yet, though. And that's it.
Wow, there's really
And I did it in less, we're 5 minutes ahead.
Are we really?
Yeah. Tony's next, right?
Yeah.
Yeah.
And if it's PDF, you'll probably get lucky with this thing.
Yeah.
You can try.
Yeah. It's not working.
Bonjour, je m'appelle Antoine. And no, I'm not going to do the whole talk in French. My French isn't that good. Today's update is on dynamic flooding. If you've been following along, we've been having lots of discussions. A lot of them went off list after Prague.
Okay.
No joy. Next slide, please.
Send up Mark.
Okay, so the issues that we did discuss in Prague, do we want lands in the flooding topology? And our conclusion was yes, so that was accepted and that became part of the draft. Next question was, how do we deal with temporary additions? If the flooding topology partitions in some way, we want to make temporary additions to it to restore the flooding topology so we can continue working. And the agreement was that we have an implementation rate limiting of temporary additions. Okay. We also had an interim meeting. We had many discussions during that meeting. The outcomes of that are pretty straightforward. We're going to advertise which links are in the flooding topology. There are going to be bits in the link attributes sub TLV and link attributes TLV for OSPF. And this is equivalent to the FT bit that came from the CC LSR flooding draft. Okay. Small bug fix. In the flooding request TLV, we listed a field as the circuit types field. This caused some implementation confusion. We really do mean it to be a bit mask of the levels. It's not necessarily the same as the circuit types. So if you send a flooding request on an L1, L2 circuit, you don't have to say both L1 and L2. You could just say L1. Okay, so small clarification. Any questions on that? Okay, next slide, please. Let's see, we did a small change to the area router ID TLV to try to compress it a little bit. That was a little bit improvement in density. We had a little language clarification. If the area leader advertises a flooding topology, then dynamic flooding is active. If the area leader does not advertise a flooding topology, then dynamic flooding is disabled and legacy flooding should be used. Okay, that's probably obvious, but we just wanted to be explicit and clarify that. One addition, if you have an area, you may find that you may want to have a backup area leader. This is not explicitly denoted by anything. It's obvious from the area leader election who the second node would be, and we explicitly allow that area leader, that backup area leader, to also advertise a flooding topology. This helps against the case where there is a failure with the area leader. It simplifies and smooths out the transition between the two flooding topologies. And let's see, we welcome Huimo Chen as a co-author to the draft. The FT bit and some of the other stuff that we took from his draft is now incorporated, so we added him as a co-author. One thing I forgot to put on the slides, we did do some work on a Yang model for this. We did not get anything ready to present in time for this IETF. Our apologies. We are looking for more volunteers who want to work on Yang. Please see me if you are interested. We think that this draft is now pretty well cooked. Some of us are trying to get this code ready to ship. We're going to ask one last time for early allocation. This is our third request.
I think we're ready for that. This is, especially now that there isn't any contention on the base encodings.
Is there anything else I have to do?
I think we have to request Alvaro to do it, and we'll do that.
Pretty please. And that's all I have. Any questions? Thank you.
Okay. Yeah, that was a pretty successful outcome of the interim, because we did have a lot of contention before that. Everything's all good now. So I think Wemo might be up next, right? So we're going to probably may stumble.
Where's the meet echo? Is it?
Yeah, do we have a Meet Echo support person? No. So we're going to, I'm hoping that, let me put Wemo's presentation up.
Yes.
Hey. Yeah, we can all see you, Wemo, on one of the screens here, and I'll pull your presentation up now. I think.
So can you hear me?
Yes.
Yeah.
Good, great.
It's this one, flooding topology computation.
Yes, that's it. I tried to put them in order just before the meeting.
Okay.
Hopefully I got them in the right order.
All right, Wemo, can you see your slides as well?
Yes, very clear.
Okay, excellent.
Hello.
Then take over.
Hello, everyone. Today I'm going to talk about the flooding topology computation algorithm. So next page. So this version of the talk is focusing on flooding topology computation algorithm. So basically, we remove everything is not related to the algorithm. We update the algorithm to consider degree of flooding topology. So for a flooding topology, so the number of connections of flooding topology is the degree of that node. For example, for this flooding topology, R1, node R1 has two connections on the flooding topology. So R1's degree is 2. For node R0, it has 3 connections on the flooding topology. So its degree, the degree of R0 is 3. So for each node, we have a degree on the flooding topology. The degree of whole flooding topology is the maximum degree of all of the nodes degree. So for example, for this flooding topology, the degree of this flooding topology is 3 because the maximum degree among all the nodes is 3. So next page. So the basic idea of flooding topology computation is that we start from a node, for example, which is the smallest node ID node as a root, and then build a tree using this R0 as a root, use some kind of radius first strategy. And then we connect every node whose degree is 1 to another node to the flooding topology we already built. And then we have a flooding topology in which every node connects at least 2 nodes. So during this computation, we will consider degrees of flooding topology. So that's the addition to the previous version. So next page. So here we have some kind of flooding topology examples computed by the algorithm. So for each of these topology, the flooding topology computed here in these examples have the degree of flooding topology 3. The flooding topology, every node on the flooding topology has at least 2 connections. So the flooding topology can tolerate for any 1 linear failures on the flooding topology. So next page. So here we just take a one simple example of a flooding topology computation. So we go through the detailed steps just to get some idea about the details of a flooding topology computation. So we consider 5 nodes flush the network topology. And then based on this topology, we use our algorithm to compute a flooding topology. So initially, we start with the candidate Q, which is CQ for short. CQ contains 1 node of the road R0. This R0 with degree 0 and then without any previous hop. The flooding topology initially is empty, and then we have a maximum degree given just as a conditional constraint, which is 3. So the first special step is that we just remove the row R0 from the candidate queue, and then put that R0 to the flooding. And then for each node connected to the R0, we add those nodes into the CQ. So in this topology, and then we will add R1, R2, R3, and R4 into the candidate queue. And at step 1, we will remove the first node, which is R1. So R1's previous hop R0, R0's degree is 0. So we can link R1, R0 into the flooding topology. So after we add R1 to R0 into the flooding topology, so we will update the candidate list. For each node connected to R1, here we have R2, R3, R4 connected to the R1, which is not on the flooding topology. Since those R2, R1, R2, R3, R4 already in the candidate list, in this case, we just add R1 as a new previous hop into the R2's previous hop site, and also add R1 to the R3's previous hop, and so on. Then we come to the second step. So at step 2, we will remove R2 from CQ. So since R2's previous hop, R0, have a degree of 2 or 1, so we can add R2 and R0, this link, into the flooding topology. And then we will update the candidate queue with the nodes R3 and R4, which connect to the R2. So in this case, we just update the previous hop of R3 and R4 in the CQ. And then the last one at step 3 is that we can add R3 and R0, this link, into the flooding topology, because right now R2's degree is 2, so it's still less than maximum degree we given, which is 3. So we can add R3 and R0, this link, into to the flooding topology. So after add this one, and then we also updated the candidate queue, and then we come to the step 4. At step 4, we remove R4 from the CQ. Right now, R4 have a previous hop R0, R1, and R2, and so on. Because R0's degree is already 3, so we cannot add a link between R4 and R0. But we have previous hop R1, R1's degree is 1, so we can add a link between R4 and R1 into the flooding topology. So we can add this link into the flooding topology. So at this point, we have built a tree of flooding topologies. So next page. So for this one, we just connect every node whose degree is 1 to another node, and then at step 5, so the first node with degree 1 is R2. So R2, we will find a node, find a link between R2 and another node. So right now, what we found is that the link R2 and R3 will be added to the flooding topology because R3 has minimum degrees. So we will add a link R2 and R3 into the flooding topology. So after this step 5, and then we only have R4. We only have R4 has 1 degrees. So in this case, we will find link between R4 and R2 because R2 has a minimum degree and also minimum node IDs. So after this step, and then we have a flooding topology. This flooding topology, the degree is 3, and then every node has connected to at least 2 nodes on the flooding topology. So next page. So here, so previously we just go through from example to get some idea what's the detail of algorithm. So here is some kind of more formal descriptions about the algorithm. So this algorithm starts from a node R0 as a root, and then this root will have a minimum smallest road IDs, something like that. And then we were given a maximum degree, and then we will have a candidate queue initially, and then this candidate queue will only contain this R0 as a road, and then we start with the empty flooding topology. And then this one, we get more details about this one. R0 is the road, and then initially the degree of R0 is 0, and then the previous host of R0 is empty. So next page. So from that start point, and then we just go through several steps in this algorithm. So basically, first step 1 is that we find and remove an element from a candidate queue, and then satisfy some conditions such as we should have one of his previous hop. That his previous hop degree is less than the maximum degree. So we should find that element and then remove that element from the candidate list, and then add that one into the flooding topology, and then we extend the candidate queue. So that's the step 1. So step 2 give the more details about how we extended the candidate queue. So connected to that node we removed from the candidate queue. And then if that node is not on the candidate queue, and then we just add that node in the candidate queue. If that node is already in the candidate queue, and then we just updated the previous hop. So that's the way updated the candidate queue. So if we all the nodes on the flooding topology, and then we will go to the next step, which is connect every node whose degree is 1 to another node, such that we have a flooding topology in which every node has at least 2 connections on the flooding topology, and then we have the flooding topology we have. So next page. So we welcome more comments, and also I think we would like to request that option. So any questions or comments?
This is AC Lindum. Is there any IPR on this? I think
Yes.
I think there might be IPR before, at some point from way back, but because a lot of people have said that we should do it based on the degree, and now this actually formalizes with the algorithm to do it based on degree. So I'm wondering if anybody knows of IPR on this.
Yes. Yeah. We will disclose the IPR. There's something to remind that. That's good. Yeah. Yes.
The other question is, I read it. I think you need to describe the usage of previous next top better in the draft. Maybe even have some of these pictures, if you could. I mean, I know it's hard with ASCII art, but it's hard to understand it. And maybe I didn't put enough time into it, but I understood it better this time with the pictures than I did when I first read it. That's my only comment.
Yeah, I agree. So with picture, it's hard to understand. I totally agree with you.
Hi, Tony Lee, Arista. When we first established the dynamic flooding draft, we did issue an IPR statement. I'm not a lawyer. I can't tell you whether it covers this or not.
Okay.
Okay. But it was a general IPR statement on dynamic flooding. Now everybody's got IPR on dynamic flooding, so I'm not trying to block anything. I'm just trying to have your lawyers go look at patent applications.
Was it Arista that issued it?
Yeah.
Do you know? Do they have like a friendly?
The language is taken from other IPR disclosures that says basically, don't sue us and we won't sue you.
Okay, good.
And we said that very pointedly, directing it to the east of us. Okay. Huemo, thank you very much for the presentation. That helped. Myself and my colleagues looked at your draft very carefully and scratched our heads, and we are very disappointed that you are not here to discuss it with us. We really want to understand this, and we're not quite there yet. Is really the intent here, the primary crux of the algorithm, to be breadth first search?
Yeah, I think that we based on breadth first search. So that is a concern. Is because when we compute the flooding topology, we also consider the diameters of the flooding topology. I think that's in some way to get a good diameters for the flooding topology. So I think not a limited one. That's just one proposal right now.
Okay, so anything you can do to help clarify the presentation of the algorithm would be very helpful to us. We're not there yet. Second, have you done anything in your algorithm to constrain the diameter of the flooding topology?
Yeah.
Okay.
Just basically use the breadth first. That will get some kind of good diameter.
We didn't see anything in there that would ensure that you didn't have a ballooning diameter, and that would be suboptimal. Maybe we just don't understand yet.
Yeah, I think just run some examples. I think that the diameter looks good. Maybe we can. I'll read more examples and to see what we will have for the diameters.
Okay, thank you.
Okay, good. I think we're going to discuss this a lot more on the list, and I'd like to encourage that. In the interest of the time, I'd like to get to the next one after Alvaro talks. Next presentation.
Alvaro Thunder Routing, just a quick commercial. As all of you are probably aware, we have a new format for the RFCs, and so you can now put actual art pictures in it. So you can look at SVG graphs, I think. So your comment of maybe figures in there would be nice. I think this would be a great opportunity to have this draft be in version 3 of the RFC. So just commercial.
And I love ASCII art too, though. So It's like if you can't manage to do the topology or it's not clear and it would be much clearer with graphics, then yeah, you do have the ability to use SVG and RFCs. I don't know if that'll be required or not, but the takeaway I think, Wemo, is yeah, it would be great if you could put some of the things you have in this presentation and maybe even some more pictures. They help a lot. I think the call for adoption, let's do another round on this. I don't think anybody has any objections to this. It's looking good, but there are some open questions. Let's work on that. And make sure that we address the questions like the diameter and stuff like that. And as long as nothing pops out that looks strange, I don't see why the working group wouldn't want to adopt something like this. Okay. So we're going to move to the next draft, the next presentation. Oh, thank you, Wemo.
Okay, thank you.
Yeah, so okay. So we have a couple of presentations coming up, but I just want to explain something on these. So we have a proposal about flooding speed advertisement that was put forward by Bruno in a draft. There's some how we got a scheduled rebuttal coming. This is sort of interesting to me because it happened to me the first time that I presented in ISIS about 20 years ago or something. I got a surprise presentation that came up right after me. Thanks, Tony Lee had Hank Schmidt come up and tell everyone why the thing I just presented was useless. So I just realized that this was a little payback, I guess, but it was totally not intended that way. I didn't realize that there hadn't been anything discussed between the two groups before this presentation was put on there. Anyway, nothing is being decided here, right? So this is just a presentation. There will be a presentation following Bruno's where there's sort of addressing and disagreeing with some of the points you're about to see. But again, nothing is being decided here. And Bruno sent us a mail. He's not had a chance to really go over that presentation, so he felt a little bit like, hey, I would have liked to have seen this before I presented, so I could have maybe addressed these points. I'm sympathetic to that. Like I said, 20 years ago, the same thing happened to me, and I didn't like it.
Thank you.
I don't know if that'll work.
Doesn't work?
It might. Wait, click it, and if it doesn't work, then no. Okay, I'll
Okay.
have it on the side for you.
Okay, so hello, I'm Bruno from Orange. I'm going to talk about a draft to improve flooding speed. So just to clarify, it's just about communication speed between two neighbors. It's not competing with a proposal reducing the flooding topology or graph. So next one, please. So as an introduction, it's probably well known to everyone, but still, flooding is very important for link state IGP. If you have a slow flooding, it directly translates to a slow reaction to failure, so packet loss. And also it translates to LSDB inconsistency, hence routing inconsistency, and you have a chance to have microloops. Unfortunately, flooding is hard. You want to be fast to have your database in sync. Especially in case of a single node failure, which is just one failure. But for link state IGP, it translates into multiple messages. So it could be N could be 10, 20, depending on your topology. So you need to be able to fast flood 10 or 20 LSPD messages quite fast, just for a single node failure. At the same time, you need to be slow in order to not overload your adjacent neighbor. So it's enough to not overload your neighbor because flooding is hop by hop. So you're just sending message to your neighbor. So it's between two adjacent neighbor. Next slide, please. So what is the status? In ISIS, we don't have any signaling to control the flooding speed. And the current status in terms of implementation is that the flooding speed is very, very conservative. So default delay between sending two consecutive LSPD is something like 33 milliseconds or 100 milliseconds, which is about 30 packets per second, or 300 kilobits per neighbor. If you're comparing to the same control plane speaking BGP over TCP, on the same implementation, the BGP polycer is set to 20,000 packets per second, which is 200 megabits. So it's 1,000 faster. So the goal is not to go to 1,000 faster, but there is room for improvement. And finally, we have the same flooding speed for the last 20 years. Even though the CPE on the interfaces speed have improved. So it probably shows that something is missing. So next one, please. So the proposition is it's very simple. It's just one TLV to be able to advertise your own capability to receive LSPD messages to your upstream neighbors. So I am the downstream. I am capable of receiving ISIS LSPDU at a certain speed, and I advertise that capability to my upstream flooding neighbor. So why hello? It's again because we are just discussing between adjacent neighbors. So that's all. One TLV in hellos. No, it's okay. Next, yeah. Thank you. So actually, we advertise two parameters in the TLVs. We try to be aligned with existing implementations in order to make it simpler and to increase the likelihood on the speed of deployment. So we have two parameters. Next, please. So the first parameter is called minimum interface LSP transmission interval. So the name is long, but it's only the delay in milliseconds between two consecutive LSPDU. So it's nothing new. It's a parameter which is available in all existing implementation. So sometimes it's called LSP interval. Sometimes it's called LSP pacing interval. Sometimes it's called LSP TX interval. Same thing. So nothing new in terms of flooding. And that parameter is akin to a CPU or processing performance. So basically, you commit that you're capable of, in average, processing some LSPDU per second. So for example, 30. Next one. Second parameter is the ability to send a burst of consecutive LSPDU. So you say, I agree that you can send me a few LSPDU back to back if you want, up to n LSP DU. It's less popular in terms of implementation, but there are implementations. It's called fast flood, for example, on one implementation. And also many implementations have DDoS filtering to limit the amount of packets that you can receive to avoid DDoS. So that parameter is akin to a memory buffer. So you can keep in memory a few LSP before processing it. So that's all. No, if you can come back. So that's all two parameters in one TLV. There is a small or a refinement is that actually for fast flood, we say it's a number of non-acknowledged LSPDU, not only the number of LSPDU that you can send in burst. So next one. So with that precision, we can go even more precisely toward flow control, because ISIS does have a mechanism to acknowledge the reception of LSPDU, basically using PSNP on point-to-point interfaces. So ISIS can already advertise the reception or acknowledge the reception of each LSP. And with that, we have a dynamic flow control, if we want. So with two parameters, the one which is the size of the burst, so the memory that you can have, which is a static transmission window. So remember static transmission window. We'll have a test in a few minutes. And then we have a XSNP or PSNP, which serve as dynamic acknowledgement. So you can acknowledge that you have removed LSPDU outside of your buffer. Next one, please. So in summary, we want to improve ISIS communication speed, so flooding speed. We are advertising two static parameters from the downstream flooding level up to the upstream flooding level, so point to point. And these two parameters match existing implementation, at least for the first one, and partially for the second one. Next one. So with that single TLV, the upstream can do different kind of behaviors upstream. So the first kind of behavior is to coordinate on the LSP pacing. So that one is very easy to do because it's already available on all implementation. But with the extension, you agree with your neighbor on how fast you can process LSPDU. And even with that single improvement, it can be significant in real life because I think everyone will agree that flooding speed is very, very conservative currently. Second behavior that you can do is to allow sending a burst of LSPDU, which is very useful for handling node failure, because in terms of if you have a single node failure, it translates it in NLSP to be flooded. So it's good to be able to advertise quickly that one node has been removed from the topology. And a third possibility opened by that new TLV is to have dynamic flow control, which would be a significant improvement compared to a static LSP pacing that we have today. But any of those improvements, it's local to the upstream flooding neighbor. The only thing that is mandatory is the TLV that is being sent from the downstream flooding neighbor. And that's all. Any comment?
I haven't read the draft, sorry. Kiriti Kampala, but it was very clear. So I have a couple of questions. One is you use the term upstream several times. In the context of flooding, what does that mean?
Can you come back? Kiriti, it doesn't sound like you're coming over the mic. I don't know. Is it on?
Yeah, it's on.
Okay.
I'm not coming over the mic.
With a diagram. Okay. So we use the same term upstream flooding and downstream flooding. The issue is that at the beginning we use the sending router and the receiving router.
I see, okay.
But there are two sending routers, the one sending the TLV and the one sending the LSPD. So it was not very clear.
You should put that in the draft because, we have one definition of upstream and downstream for MPLS label assignment. We have another one for multicast. And so in the context, it's not, it would be good to describe that early in the draft.
Good point.
Thanks.
Okay. So in general, the upstream is that the one sending the packet downstream. So, but the packet is the LSPDU in the case of ISIS.
And the second thing is the interval that you suggest in milliseconds.
Yeah.
Should you maybe do it 100 microseconds or something else? Because millisecond means you can only do one per millisecond, which means 1,000 per second. Depends on your burst size, but it still limits. And you just said that BGP does 20,000 per second. So maybe let's not stick to milliseconds because everyone uses it, but let's use a number that makes sense.
I had the exact same comment. When I read through it, I thought the bits in the TLV are pretty cheap.
Yeah.
You could just make these 32-bit instead of 16-bit and call it microseconds or whatever, right?
I fully agree. Thank you for the comments. We already received the comment by email. It was a bit too late to change the draft. But I agree that milliseconds could be limiting in the future. Even though I would be already happy if we could reduce up to 1 millisecond, but you're right. Absolutely. Thank you, Kiriti. Jeff.
Just zero. So to my memory, fast flooding has today scope of an instance, right? It's applicable to instance. You are moving into super adjacency. So theoretically, if you have 10,000 adjacencies and everybody signals different interval, you'll have to create state per adjacency, and it will create some problems. How?
What problem?
So today you generate updates. You send them the same pace to everybody, right? Here you are introducing per adjacency state.
Well, you already have per adjacency.
You already have implementations which have LSP pacing per interfaces. So it's nothing really new. It's already, I don't know, for all implementation. Okay. I don't want to give names, but yes.
Okay. So now I guess we'll take the remaining. I was willing to let that run over as far as it wanted to go. Now, I guess Les is going to present his opinion along with AC's and Peter's on this work. Bruno did not get to view this ahead of time, or the other authors.
While you're bringing the slides up, I'd just like to make the point that Bruno and I actually do talk to each other, and I'd like to think we're not enemies. So even though I'm going to disagree with some of the things he said, there has been a fair amount of communication.
Was that on the list?
No. Well, no disagreement. Okay, next slide. So just the very quick review of what Bruno's just presented. I took some poetic license here, and I changed the names that you have in the draft just to emphasize the point that what's being specified in the new TLV is from the point of view of the receiver. So this is the minimum interval in which I would like to receive LSPs, the minimum interval in which I would like, the minimum burst that I would like to receive. And this can potentially be adjusted dynamically, although I believe there's language in the draft that says it's not a good idea to do this too often. Okay, next slide. So here's what we agree on. We definitely agree that flooding, at least as it's been defined historically and defaults in most implementations, is much too slow for modern networks. So we agree that we want to allow for the capability to flood much faster than we do by default today. But we also agree that doing so entails some risk, and therefore we want to have some means of flow control. Next slide. Here's what we disagree on. The essence of the draft is to send parameters that control the state per interface. I think this is related to the point that Jeff was asking about. It isn't. The value that you want to use for flooding is not a per interface value. And I'll go into a little more detail here. The second point is the draft specifies that flow control should be managed by the receiver, and we believe it should be managed by the transmitter. Next slide. So flooding is part of what allows you to achieve network-wide convergence. Just as we do with SPF intervals, if you configure vastly different SPF intervals on different nodes, the convergence behavior in the network is going to suffer because some portions of the network are going to converge significantly faster than other portions of the network. Same thing is true with flooding, because if I run my SPF, but the information I'm running my SPF on doesn't match that of my neighbors, then I'm going to come to a different conclusion. I'm going to temporarily install different routes in the forwarding plane, and I'm going to be vulnerable to loops and black holes and so forth. So we strongly believe that the value that you want to use for pacing your LSP flooding needs to be a network-wide parameter, not a per interface parameter. Next slide. This is, I did some archaeological research here. Back in ISO 10589, there's actually some language in 10589 that reinforces this point. The language here specifies that this is talking about the retransmit timer. The retransmit timer is per LSP, but it's not per LSP per interface. It's simply per LSP. So if I need to retransmit an LSP, then I want to do so at the same time on all of the interfaces on which I have yet to receive an acknowledgement. I don't want to tune this to a per interface value. This maximizes the possibility that all the nodes in the network are going to converge on the same LSP database in a more consistent manner. Next slide. Receiver-driven flow control. The ability of a node to decide, gee, you know, I'm getting things too fast for whatever reason. My CPU is overloaded. My punt queue from the data plane is overloaded. Whatever the reason may be, many implementations implement an LSP input queue as simply a FIFO, not a per interface FIFO, but just, well, no matter what interface I got this in on, I'm going to stick it into a queue. And when I get around to processing that queue, I'm going to process them first in, first out. So if that queue, which oftentimes is bounded, if that queue gets overloaded, okay, it's an indication that I'm getting swamped, but who's swamping me? Unless I actually go through and process the LSPs in the input queue, I can't figure out who, you know, which of my neighbors might be the one who's sending stuff to me too fast. And in addition, you know, based on the points, you know, we made in the previous slides, I don't really want to have a per interface, you know, a slower rate on one interface and a faster rate on another interface. So the rationale for saying I want to advertise a slower rate to this one neighbor, but allow the faster rate to some other neighbor, is both a problem from an implementation standpoint. It is not the behavior we want in order to optimize network convergence.
I'll jump in here since, I mean, just to make clear, you're making a point based on assumptions about implementation. You're saying, I don't know who sent it to me because my implementation uses a single FIFO LSP queue. I mean, so yes, for an implementation that uses a single FIFO input queue for LSPs, this is not easy to implement and not a good solution. But it's not. That doesn't mean that for all implementations of ISIS, this is hard to identify who's sending you the LSPs.
So I'm not necessarily going to disagree with you. There's a number of points being made here, and I think one of the points is there are implementations that do this. More than one from my personal experience. That doesn't mean all implementations do this. And there are some good reasons for an implementation to implement it this way.
Yeah, no,
so,
I agree. This is kind of the
but,
back and forth.
Yeah,
on the mailing list,
sure,
you know, like,
sure.
Because, you know, you might want to not implement your implementation that, you know, when you chose to do the single FIFO, you didn't have something, you know, there were different considerations and it made sense to do it that
you
way.
know,
Anyway.
I could counter by saying if I do this per interface, now I got to come up with a fairness algorithm. Anyways,
Yes.
let's not debate that. The second point I want to make about receiver-driven flow control, well, actually, sorry, can you go back one slide? I may have missed something here. Yeah. So the sending of the updated receive interval is essentially an out-of-band signaling mechanism. Okay, I detect the condition where I want to tell one or more of my neighbors to slow down. I'm doing this at a time when I'm very busy. If I'm very busy, it's quite likely that my neighbors are very busy. And at this point in time, I now have to send additional PDUs. Okay, in other words, for this to be effective, I can't wait 10 seconds until my next hello interval. That's going to let the condition persist for much longer than I would like. So I've got to introduce extra processing both for myself and for my neighbors, precisely at the time when everybody's the most busy, which to me is a disadvantage. Next slide. This obviously depends on some protocol extensions. So it's not going to be effective if I send this, but my neighbor doesn't support it. So I have to wait for everybody to upgrade to get the maximum benefit out of this. If you do this in a brownfield, you're not going to get the full benefit. Next slide. So what should we do? Okay, ISIS 101, what do? When we have an LSP to send, we mark it with a send routing message bit and the SRM bit. And I'm talking here strictly about point-to-point. We know broadcast interfaces work a little bit differently, but for the purposes of this discussion, I think we can stick to point to point. The SRM stays set until we actually get an acknowledgement on that particular interface. The retransmit timer will fire, and we will resend any LSP that has been unacknowledged. From the transmit side, I know how many LSPs that I have for a particular interface that I have sent that I have not received acknowledgement for. I have all of that information, okay? And when I have that information, I don't particularly care why the LSP was not acknowledged. Does my neighbor, does he not have enough CPU time? Is his receive queue too small? Did he have problems in the punt path? I don't care. All I know is that I need to be retransmitting, and I've got all the information to tell me how big the retransmit queue is. So using this information, I can do flow control from the transmit side. I don't need any protocol extensions. I don't need any extra signaling from my neighbor. Next slide. This is just one potential algorithm. It's not an algorithm that I'm intending to, to say this is the best or the only or whatever. But basically, you set an upper bound for your unacknowledged LSPs on a particular interface. When you hit that limit, then you slow down the rate at which you send LSPs to that neighbor, and you persist in doing this until the number of unacknowledged LSPs goes below some safe limit. Then you go back to your default setting. When this condition occurs, I think this condition should be logged because, as we discussed before, we want to have a consistent flooding rate on all the interfaces in the network so that we can get the optimal convergence. And if you have a node that is consistently not able to keep up, then the convergence in your network is going to suffer. And you need to let the operator know so the operator can decide what does he want to do about this. Does he have an underpowered node? Does he have a misconfiguration that's causing, too much traffic to go to this node? What does he want to do? Does he want to slow down the rate across the whole network? He's got many choices, and we need to let him know that this condition is occurring. Next slide. So there's a bunch of things in this space that actually have been done and are out there. Fast flooding's been around for close to 20 years. As part of fast flooding, or fast convergence, I should say, as part of that, we have some kind of fast flooding knob that says, before you actually start your SPF, send a bunch of LSPs to your neighbors so that we can speed up the propagation of LSPs through the network. So we increase the probability that when everybody runs their next SPF, they actually have all of the updated LSP database. Yep. Am I running out of time? Okay.
I mean, if you want to summarize more on that slide, we have some slack in the next slot. So
yeah. So it was just the point on the slide. There's a number of things that have been done. People are actually flooding faster than 33 milliseconds, and they've been doing so successfully. I haven't heard about any problems with that. So it isn't like we haven't just been able to turn this on and it doesn't work. It does work. Next slide. So what should we do? We should encourage vendors to increase the flooding rate. We need to emphasize the point that this is a network-wide parameter, not a per interface parameter. Use the TX-based flow control. We don't believe we need protocol extensions. Do we need a BCP draft? If it was up to me, probably not, but I can be convinced.
So I think that a lot of good work can be done on this. I don't think that anybody has the right answer yet. I'll throw out my couple of comments quickly. Who ever heard of receiver-based flow control? What a crazy idea, right? Or out-of-band signaling, RTS, CTS. I mean, it's not crazy to want to do receiver-side flow control. But that said, I think you have some valid points that need to be discussed, like the different types of, if you're flooding at different rates on different interfaces, you're getting, thing that, again, though, that one could argue both ways, right? Because as long as you get flooding is about getting it everywhere as fast as possible. So if it's not going fast on this interface, maybe it's going fast on another interface. So I'm not sure if that's a big deal, whatever. We can discuss that on the list as well. But so it's good to have, I think, two points here, though. You've got a good point about, hey, I've got retransmits. I can do transmission side flow control that way. I think that the other authors have a good point about maybe we need to look at receiver side. I don't know if this is, I wish this would have happened on the list first, right? Like, why didn't these comments come out after the draft was published? I'm not attacking you. I think that would have been a better way to approach this than a presentation.
Yeah, but it did all happen very quickly, but by around the draft cutoff time. So,
well, but there was time to put together a presentation, right? Yeah. And there's no mailing list cutoff time.
Tony P. Juniper. Yeah, so too many drafts, too little time. Overall, I largely agree with Les from long experience. The different rate causing transients on the network is very pronounced in sparse network. The denser the networks get, the less that is an issue. You actually flip into the other side. So the per node behavior is largely an artifact of a very, very old spec that has been a little bit too specific how to implement these things, right? So if you have dense networks, and with modern techniques, the per interface is doable. So it depends which part of the design space you're in. The constant rate indicated per second is definitely not enough. Things change very, very quickly. And Les gave you already a large part of the solution. You should basically look on the sender more on the losses. Okay, that is a much simpler technique. And don't ramp up too aggressively. I mean, you have it slightly hidden, right? Like, so don't be too optimistic when things go well. But you can also know where you don't have enough throughput when you want to really bump up. There is also a very good technique for that. So I agree, BCP is probably all we need. Lots of these techniques are already around, and roughly what Les suggests is practically very doable. I would only disagree at the per interface. I would go per interface, especially on the dense networks, because then the slowest receiver starts to actually choke you. If you have a lot of interface, and the slowest guys can clamps you down on flooding speed. Okay.
I think that there's a reason for a draft, no matter what our resolution is, because while you said that yes, people might be violating the 33 millisecond rule, it is a violation of a standard, and so you can get into these realms where you get operators who run a test that says, "Are you standard?" Right? And if you say, "But look, you're sending it faster than 33," and then you have to do this justification. Whereas if you have a document we can point at saying it's 20 years later, we think we can send it faster than 33, so we're revising the standard to now be whatever.
So one minor archaeological point. Yeah. If you actually look at 10.589, the 33 millisecond is specified only for broadcast interfaces. There is no statement for point-to-point. Yeah.
Yeah, because I remember that actually, because you can blast things as fast as you want on a point-to-point, and it's expected. Layer 2 is expected to take care of that.
Yes.
Chris Bowers with Juniper. Could you go back a few slides? Because most of your arguments are fairly superficial and inconsistent with one another.
Don't hold back, Chris.
No. Could you go back? Let's see. That one here. So you say updating hellos dynamically to alter flooding transmission rate is an out-of-band signaling mechanism consuming resources at a time when routers are the most busy. But you also did read the text in here that says these should not be updated very often. And in fact, there's text that says basically do it at configuration time. Explicitly do not, it would be a bad idea to adjust these advertised values as a function of CPU load.
So are you saying the intent from your mind of the draft is simply to set these once from the receive end and not to change them?
Yeah, on the scale of several hours, perhaps.
Okay.
So how do you feel about that?
It doesn't change my point of view, but it does mean that if you're, yes, if you're not going to do dynamic signaling, then this point is moot. I agree.
Tony Lee, Arista. In BGP, we have this thing called the slow receiver problem. And we've been through this problem several times and iterated many times. And basically, the answer is there's not much you can do about the slow receiver except log it. And I understand.
Just 1 second. Let's no more people at the line after the last person who came up.
I agree that we want, for convergence reasons, for things to converge uniformly. Absolutely. I don't think the right answer is to slow everything down to the least common denominator.
I agree. That was not the point I was trying to make.
So then we should be able to go fast where we can go fast. And to do that, we actually have to have real active flow control. And that kind of implies we have to have a control loop. Okay? And the way for us to do that, the control loop, the receiver has to give you some feedback on the state of the control loop. So now I'm going to disagree with some of my co-authors here and say, no, actually those numbers need to change, and they need to change pretty rapidly. It looks just like a TCP receive window. Okay?
That's less the solution, right? Watch the drops.
No. Drops is not enough.
Yeah,
No, I agree with Tony on this point. The problem is TCP is a point-to-point connection. That's not what we're talking about here. We're talking about flooding network-wide.
We're talking about flooding point-to-point here.
No. I'm saying a TCP connection is between node A and node B, however many hops they're separated in the network. You're controlling the flow between these two endpoints only. That's not what we're trying to do with flooding. We're trying to get the flooding out to the whole network as fast as we can, as consistently as we can.
The best way I know of doing that is to move the packets from point A to point B, and neighbor to neighbor, and use the bandwidth that we've got, and use the CPU power that we've got. Okay? So it seems like the way to do that is to have the local control loop run as quickly as possible. Now, I'm going to, again, go out on a branch and say I disagree with my co-authors. I think that this TLV should also be in the PSNP packet. Okay, so now when the LSP receiver has processed part of its input queue, it can now send upstream, say, okay, I've both processed this much, here are all the things that I'm acting, and oh, by the way, here's how much buffer space I've got left. Now that could be less than what has already been sent. So that's also, that can both be positive and negative reinforcement to the transmit. Okay. Thank you.
So again, this is very interesting. I want to point out, I know we're out of time, but you raising the point about point-to-point not having anything said about it in the ISO standard is, I think, why we're here. Because they were literally relegating this to the L2. And they were saying, send it as fast as you want, right? And L2 will take care of you. And it isn't for us, right? And now we're here trying, from both sides, whether transmit or receive, we're saying, how can we speed this up? Because we've been using this broadcast minimum on the point-to-point link. It's interesting.
I just want to point out that OSPF we'll discuss this more on the list. OSPF has never had anything mandated. It's all been implementation.
I'm going to do the kind of range. I have comments on mostly all slides, so I don't know how much time I have. So let's start with slide 2, for example.
No, you don't really have to. You don't have that much time. Do you have a main point you'd like to make?
Main point, in my opinion, flooding is point-to-point. It's between two adjacent neighbors. So I have LSP, which are newer for you. I have to send it to you, specifically to you. I don't care about your neighbors. It's point-to-point. Second, maybe we disagree, but I disagree that we need to flood at the same speed for all interfaces or all neighbors. I could find an example, but I'm not sure we have time. But we can find an example with topology of 3 nodes. And I can give you an example. It's better to flood fast if you can flood fast. In the end, the issue is to delay the LSPD flooding. Because if you delay the LSPD flooding, you have LSDP which are out of sync. full point.
Mhm.
We just want to be fast if we can be fast. So the point of having different delay per level is not urgent to be. If you disagree, we can discuss that by email or now, depending on the time.
Yeah, I mean, the point I want to emphasize is you and I fundamentally agree flooding is much slower than it needs to be today. There's no disagreement about that.
So we need to improve flooding to reduce the delay. If you can reduce the delay, we agree that it is point-to-point communication between two levels.
No, the point I want to make is that flooding is a network-wide parameter. If I flood slow on one link, I'm affecting convergence in the whole network.
I agree that you flood fast if you can, but if you can't, I think we need to flood fast on the neighbors which can flood fast, and if you need to flood more slower to someone, well, you have to do slower, but there is nothing else you can do. Yeah. There is no reason to reduce the speed on all levels.
I also agree with that.
This sounds really good. We should have this conversation on the mailing list.
So why do we have slides to do the conversation?
What's that?
Why do we have slides instead of doing the conversation?
Because this is the way it worked, I guess. If everyone's going to be here for the second session, if we have, when we run out of time later tonight, we can all just sit around and talk about this.
Okay. Thank you. Yeah. I have also comments.
Rick Taylor, I'll try and keep it very quick. I'm coming in quite cold to this. I'm not an OSPF or ISS expert, but I understand both sides' points. I think you have different ends of the same stick here. You want to solve the same problem, and I think you guys can get that solved. Either the sender can monitor acknowledgement or do flow control, or the receiver can provide feedback, or perhaps both. I think one thing that gets missed, and you're conflating 2 points. One is how do we control the point-to-point control plane rate? And the other point, which you keep coming to quite elegantly, is in a link state routing protocol, the critical thing is about the consistent view of the link state database across the entire network. So if you want to speed up the propagation of that link state across the entire network, that's almost a different parameter and needs a different method of speeding up than just rate controlling your point-to-point link. They're both important, and 33 milliseconds is too old a number.
Okay.
But something that there's those 2 points, if you can separate them, you can get there, I think.
You're higher. Okay.
Okay, Tony's going to go next. We do have a plan for catching back up. Part of it is Tony had originally asked for 5 minutes for these, and we gave 10. So any for each of them, any help he can give us. The other thing is we can push Peter's last presentation to the next session because we only have 45 minutes allocated in the next session. So
Tony's going to talk fast. All right. Got 2 updates for you: topology transparent zones, area abstraction, and hierarchical ISS. Next slide, please. Okay, first, topology transparent zones and area abstraction. As previously noted, this is largely trying to accomplish the same thing. We have completely different ways of doing things. We at least have met and privately and have agreed we're going to collaborate. We have started a document offline. We do not have anything ready to present. Sorry. Okay, next. Hierarchical ISS. So we have some changes here. We added support for flooding scopes. There was a bug fix. We needed more PDU types for LAN IIHs. That was just silly. We added an explicit area identifier because apparently nobody in discussion was willing to actually deal with hierarchical NSAP allocation. Does anybody here remember what NSAPs are? Oh, good. Okay, that's probably the right thing to do. We welcome Les and Paul Wells as co-authors, and we are again asking for working group adoption. Done.
My apologies on this one. The the wrong versions of the draft. This draft got included in the meeting materials, and I didn't notice it till I was reading it on the plane. So sorry.
So we had a offer last IETF by Tony Zagenda to present all the reasons we would never want to actually deploy hierarchical link state routing. And then I went and asked him for this, if, would he please present that? And he said, no. So that's pretty bad. I wish he would have. I don't know. What do you think? What are your? I haven't really thought about working group adoption call. I guess we can just ask the working group. Yeah.
And hopefully, people will, if you have some trepidation regarding this this step forward to multiple levels, please come forward.
Yeah, I mean, so the reason I'm sort of hemming and hawing, right, is because I don't think people are paying attention, right? And some people who are paying attention are saying this is a bad idea, but then they're not willing to get up and show us why. So I just don't want to jump the gun here and adopt something that then later we get somebody coming in and saying, "What the hell are you working on this for?" Right? This is a crazy idea.
Rick Taylor, just very quick question. Have the potential use cases for this been documented anywhere? Is it in the top of the draft? I haven't read the draft.
Yeah, I think that Tony's got it in there, basically saying, the obvious ones. Reduction of state.
Are those use cases contentious?
Not very. The main use case is called scale. We've got this thing called the internet. We've got domains that are busting out of their seams. For many, many years, people have been doing strange things. They've got an IGP running in North America. They've got an IGP running in Europe, and they paste things together at the edges, or they run distance vector between the two. All sorts of strange things happen. What we're finally trying to do is get around to doing the work of adding additional hierarchies so that we can continue to scale. When the protocols were initially designed, these kind of scale numbers were out of the design scope, and it's time to add.
Hi, Tony.
Tony P. Juniper. So since you publicly tried to
shame me,
my height is about that thick, and then there's this asbestos suit on top of that. Okay. So if you're really interested in the reasoning, you can access it by reading up the PNI spec and think why we didn't. Yeah, right. That's where it's been done, and why we didn't build the BGP on top of the areas, PNI areas, which would have been necessary if we wouldn't have a crankback. The only way we could avoid that, we had the crankback, and the crankback allowed us to, when we screwed up, back off and find a feasible path, which you don't have in IP, you simply black hole. Okay, so that's like a meta one sentence thing. Thanks.
So hopefully in your IGP, you don't have policy restrictions that cause paths to be invalid, and therefore you don't need crankback, and therefore this should just work. Yes, all comments about suboptimal paths because of abstraction, yes, those are well known, stipulated.
He also raised, Tony, can I ask you a question quick? Yeah, he has Tony was talking to me about it, and he said also there might be some issues with when we're level 1, level 2, if you get why am I dropping it? You get cut in half, right?
Area partition is a separate problem, and yes, that's something that we can talk about.
Does it get a lot more complex when you're getting into multiple layers of areas?
No, because you're just going to make everything hierarchical, right? So anything you do to repair a L1 partition via L2, you would do to heal an L2 partition via L3. I mean, the whole point is to have same mechanisms at every level.
All right. Well, so the author is asking for working group adoption. How many people have read and thought about this work?
I read it once.
I got to say again, I read the wrong version, and I figured out why. Somebody asked Tony to rename his draft to have LSR in it, and the agenda still referenced the old one.
Okay, so there was a decent number of people. How many people? How many people would like to see this become a working group document? A lot less, but okay. Is that how many people have been influenced by me being negative in their raising their hands? Okay, there's a few. All right. Sorry. Okay. So, all right. Why don't we just put it to the list then? We'll just ask on the list and see where it goes. Okay. Thanks, Tom.
So we have less invalid TLB. Yeah, just while this is coming up, I just like to encourage everybody not to read the one that has LSR in the name, not just Lee. This is Lee LSR instead of right.
Does that work? I don't know. I'm like editing his slides instead of just.
Is that because you know I'm going to give you grief?
I don't know how to. Is it usually at the bottom or something? The view.
What is this?
It's like a Google editing the present here.
Okay. Yeah.
Okay. It might start going out.
Okay, next slide, please. This will be pretty short. What did we change? Oops, not that short. I'm trying, Chris. Okay, just a quick, this has been presented several times before. What motivated this draft? We actually had some real world interoperability problems and how people decided whether to reject an LSP in its entirety. And we needed to clarify what you do. Hey, if you got an unknown TLV or a TLV that's malformed, you can't use the TLV, obviously, but you cannot throw away the LSP. If you throw away the LSP, then we get inconsistent LSP databases in the network, and we're never going to work. There were some issues with purges. Anyways, these are the reasons that we wrote the draft. Next slide. We got some comments from Bruno, thank you, largely editorial, but they improved the quality of the document. We put them in. There was a last call started on June 12th, and there was a considerable amount of support, no objections voiced, but it was never declared finished. This is where you get to say something.
I see the slide. Yeah, okay. So that's called.
Okay, so on the assumption that working group adoption has actually occurred, even though officially it has not, the authors believe we're done, and we'd like to ask for last call.
I think we at least need to adopt it and take it through one cycle before the last call, just one.
Okay, I'm just making the point. You know, we don't have any feedback.
So you'll get the email from one
Sure.
of us, but you can go ahead and name it IETF, LSR, ISIS, whatever.
You know, kidding aside, the point what the authors are trying to make is we're done. We don't have any outstanding comments. So from our point of view, there's no additional work planned.
Sorry, I'm red.
But you're hiding it well.
Okay. Thank you.
To top it all off, somebody spilled coffee on my laptop, and I got it restored, but they told me I shouldn't have local folders, so I was not to restore the Mac library. And I had all my IETF mail in my local folder, so I lost them all.
Oh, that's much better than my experience, which is I just forgot.
Yeah.
I should have said my dog ate first.
I actually had a new laptop restored with most stuff in 3.5 hours.
Nice. Did I get it right? Is this the right presentation?
Yeah. Okay, so my name is Peter Pshenak from Cisco. I'm going to give a quick update on the ISI SRE6 extension. Next slide, please. So the draft became a working group document, so it's been adopted. It's a good news. So one of the things that we clarified in the draft is that we explicitly said, so what the draft says is that the algo 0 locator should be advertised as a prefix. The reason is that we want things to work in a network where there are routers which don't support SRE6, which is obvious, but we never really said what do we do with the algorithm other than 0. How do we advertise? So we basically put a sentence in the draft saying we should not advertise these as a prefixes, but only as a locators. The reason is that if you have an algo X in the network, you really only want the routers which are participating in that algo and is supporting the algo to actually see that prefix. So what we said is they should not be advertised as a prefix, but only as a locators. So that's a small clarification. Next slide. So we introduced an optional sub-TLV for advertising the seed structure. It has a bunch of blank fields, which is a locator block, node and function and arguments, where we basically describe the structure of the seed. This is an optional sub-TLV of the end-seed sub-TLV and index or land index seed sub-TLV. Okay, next slide. And one other thing that I want to propose here in the last IETF and in a previous version of the draft, we introduced an A bit as a bit in the locator flag field, but after discussing with some people, we thought maybe we should move really the A flag to the prefix reachability attribute flags. So it is also used outside of the SRV6, as it seems to be a good idea to know that a prefix is an anycast prefix. And we do support these flags, attribute flags, under the locator TLV. So unless anyone implemented this, we would propose to move this to the attribute flags TLV.
In the attributes, we already have the end bit. Can that?
So ambit is different. Ambit means that I'm a node, right? That is advertising.
That also means I'm not an anycast.
Can you state your name for the minutes?
Yeah, but it's still, if something is anycast, you may want to be sure this is an anycast prefix, because not saying it's not introducing or not including nbit doesn't mean it's an anycast. So having an nbit means it is not anycast, but not having nbit set doesn't mean it is anycast. So we want to explicitly know this is an anycast prefix.
Yeah, so why would you really want to know, what's the use case to know? So I understand nbit, you probably will use it for like your TILFA path or something.
Mm-hmm.
Why would somebody want to know is it really an anycast or not?
So here in the locator, we want to know, and we don't want to use the seed from the locator if it is for TILFA, for example, right? In the prefix, what if you don't have any prefix with an N flag, right? I mean, look, I'm not saying this is a must. We just felt this A flag would probably deserve to go to the more generic sub-TLV, and the sub-TLV is available under the locator. So.
What about if the prefix is getting re-advertised from two different nodes? Would it have A set or A reset?
So, are you saying between if they are leaked or redistributed, or?
If they are leaked from two nodes?
Mm-hmm. But then we have the specific flag which are saying this is leaked prefix, right? So it's not an anycast prefix anymore.
So anycast, you mean they are assigned to a loopback on two different
Yes.
nodes?
Yeah. Yeah. Exactly. Yeah. So I'll actually, what I plan to do, I put this question on the list and see, because if anyone has implemented the A flag in the locator flags field, we don't want to cause problems, but if not, I think it would be worse to move it. Okay, next slide. All right, so we have multiple implementations. I guess we need to work on it. Any other suggestions, comments? Okay, that's all.
Yeah. AC Linder speaking to working group member. I think I agree that the Anycast flag is more a generic prefix attribute rather than being specific to SRv6. I'd like to point out, due to Tony and Les being quick, we're right back on time.
Okay, so as has been mentioned in the previously by AC, I'm going to just give a quick update on the entropy label capability and the depth signaling using ISIS and OSPF. So you can go next slide. So I'm going to cover. Okay. So what yeah, this is just, I'm covering both of the drafts. So what we did is originally the entropy label capability was advertised as a node attribute in the router capability TLV. We moved it out of the router capability TLV and we put this under the prefix advertisement. The reason is that the routers may not know the identity of the prefix originator in the remote area or a domain. And even if they know, they may not know the capabilities of that originator. Okay, next slide. So we basically introduced a new bit in the prefix attribute flag sub TLV, which we call an ELC bit. And what we said is there are some rules that if the router supports ELs on all of the line cards, it should set this ELC flag on every local prefix it advertises. If the router has multiple line cards, the router must not announce the ELC for any prefix that is locally attached if it is not capable of processing ELs on all of its line cards. The leaked prefixes should preserve the ELC signaling, so we should do that during the redistribution. So this way we can get, in a way, in the best way we can, really the ELC support between the areas and the domains, and that was the purpose of the move from the capability sub TLV or capability TLV to the prefix advertisement. So it's not perfect, but this is the best we can do. Okay, next slide. So the depth advertisement, that didn't really change. It stays as a new MSD type in a node MSD sub TLV. And basically, if a router has a multiple line cards with the different capabilities of reading the maximum label stack depths, the router must advertise the smallest one. This is the rule that has been there even in a previous version of the draft. Okay, can we go next slide? So similarly, we did the same thing in the OSPF. We removed the ELC signaling from the router information LSA. We moved it to the prefix advertisement. So in OSPF v2, it is part of the extended prefix TLV. In OSPF v3, it's a new flag in the OSPF v3 prefix option. And the same rules has been mentioned for ISIS applies here too. Okay, next slide. Here again, this hasn't changed. We have a new MSD type, same rules as in ISIS. So I guess this draft is now probably close to a working group last call, I would say.
So you said that it wasn't a great solution. It was just one that worked. I mean, the thing that pops into my mind is that we went from a piece of state attached to one thing to attached to many things.
Yes.
Yeah. I mean, did you go through a list of other ideas, like how else could I mean, or is it just because of leaking and stuff? There's just
it's just the leaking. Yeah, you have on the prefix when you leak, right, or redistribute. How else can you do it?
Yeah.
Yeah, Ketan.
Ketan Talalikar, Cisco. So I completely agree with the new proposal, doing it as a prefix attribute. But I wanted us to think again or question about removing it as a node attribute. There are some applications like traffic engineering and all of that, which would benefit from learning the EL capability from the node. Otherwise, now I have to, I have the node, but I have to look for some specific prefix in there, look at that attribute, and then figure out that the node is capable of.
No, look, I don't disagree, but question is, do we want to have two ways of signaling the same thing? And I guess people would say probably not, but I understand.
Yeah, Les Ginsburg. Ketan, my response to that would be, if you're doing any sort of traffic engineering, you have to have the router ID of the node, which means you have the prefix advertisement, and therefore you have the capability.
Okay. This has been part of the discussion which we had, and it was on the list, so I guess we closed that. This is the best we can do.
Now that you say that, in OSPF, the router ID is not necessarily, but you're going to do traffic engineering, you need
most practically, which means 99.9%, it is a reachable prefix.
And if you're going to do TE, the TE router ID is always routable.
Yeah.
Right? Yeah.
So I don't think that would be an issue anyway.
The thing that I didn't think about this. If you do advertise AC Lindum again, ERLD, doesn't that imply that you support?
Yeah, but yeah, go ahead.
Yes, it is. As soon as you are advertising the ERLD, you know that the node is supporting entropy label catalog.
So you could definitely, if you wanted for the node level, you could just advertise your ERLD.
Which we do.
Yeah, which we do.
As an MSD.
The other thing was, again, I mentioned support. Kenton's going to add the BGPLS rather than queuing yet another BGPLS short draft on the IDR queue.
We would certainly welcome his contribution.
We promise to do it quickly.
Even better. Okay, we go to the next one. All right, so here's an update on the Flex Algo draft. So originally when we wrote the draft, it was written in a way that we specified the how the Flex Algo forwarding works in the SRMPLS data plane. And then for any other data planes, we said it's up to the, that data plane or that application, how do they want to use the outcome of the calculation. We still keep the same thing, but we added the SRv6 data plane. There's a new section which describes how does this work in an SRv6 environment. To make it very, very short here, and you can read the draft, but basically in SRv6, the locator itself is attached to a topology and the algorithm. So the locator itself has a notion of the algorithm, and that's how the forwarding is being done. So we added the new section, and we also added wherever it was appropriate, the SRv6 data plane statements all over the text. And next slide, please. Okay, so the initial draft said that we can do flex algo optimization inside an area, and then between the areas or between the domains, it's up to the controller to figure out what is the best path overall. Because as we do the calculation, which is area bound, we can only find the flex algo best path inside the area. So just giving an example, if we have these four routers, I want to go from R1 to R4, and I have the IGP metrics of 10 everywhere, and then the green numbers is the delay. When I leak the prefix from right to left, R1 is going to see that it has delay of 100, to get to the prefix with a metric of 10, which is being advertised from R2. So his metric is 110. The same, the other pass would be 210 going to R3. So he's going to pick R2. But overall, end-to-end, the delay is better to go the bottom pass. But because we didn't have a way to signal the flex algometric in the prefix, we couldn't really optimize this. And we said, well, we can do this via controller. But it looks like people would like to use this without the controller. So we are trying to solve this problem here. Okay, next slide, please. So obviously, the way we can solve it is that we introduce the per flex algometric. We don't think we need this to be advertised with the prefix inside the area. This is mostly useful when we leak or redistribute the flex algo prefixes and, you know, the labels or locators. But we really want to keep the metric which has the optimization in place so we can calculate end-to-end path. Now, obviously, we cannot just put the metric in the prefix advertisement and start to use it, because we need to understand that everybody who is doing the calculation uses the same thing. So by introducing the metric, we also need to introduce something in the flex algo definition which would say we want to use this metric. And that is the next slide. So we introduced the new sub-TLV of the flex algo definition TLV, which is the definition flags. We introduced one flag, which is an M flag. The next slide. And M flag says that when the prefix algo-specific, flex algo-specific metric is used or advertised in the prefix, we must use it. If it is not there, we revert back to the standard IGP metric. So that's the definition, and everybody needs to basically agree to this definition and understand it before we can get the consistent calculation results. So it's similarly defined for OSPF, and there is a registry for those bits which are IGP agnostic. This is like a common registry defined in the draft. Okay, next slide, please. And this is the algometric. Basically, it's advertised as a sub-TLV of the prefix reachability TLVs, and it's just a 32-bit metric value, and similarly defined in OSPF. So if you have any comments, questions on those changes. If not, I'm done.
That's it for the session. How much time do we have? 10 minutes. 10 minutes.
Right. No, we can't do the Yang.
No, okay.
Because of the net mod. Yeah, we're overlapping. But we could do the next one after that.
That's link bundles.
Yeah, let's do it.
Link bundles, yeah. Note that we have the ISIS draft that Stefano did on the RFC queue for the equivalent function in ISIS.
Yeah, thanks, Stacey. So yes, we have the ISIS one. It's in the RFC editor queue. We've got a request use case for doing the same with OSPF, and that's where we have this draft. Go to the next one. So I think the problem statement is known or well understood, but just kind of going over it again. OSPF runs over layer 3 lag interfaces, and for certain in certain deployments there's use cases for performing either some kind of a OAM verification of the underlying member links, or doing some kind of a traffic engineering steering over specific member links instead of doing the hashing. And in order to enable these use cases, there is a requirement that member links actually get described and exported as part of the OSPF topology advertisements. Next one. So what's proposed in the draft is that when this use case is required, or when this feature is enabled, that OSPF router actually describes the layer 2 layer 2 members of that bundle interface. So it's basically the description of the link and some specific attributes of that link. And this is applies to both OSPF v2 and v3. Now, a key thing to note is that this does not change the OSPF route computation or SPF computation. So it's some information which is getting advertised out via OSPF. Next one. So how is this done? So there's a new L2 bundle member attribute sub TLV that we have introduced. In OSPF v2, this would be under the sub TLV of the extended link TLV in the extended link opaque LSA, and in OSPF it's part of the new extended LSAs. So it's a extended router LSA, and this is a sub TLV of the router link LSA, which in both cases they actually describe the layer 3 link. So that's a TLV proposal, and mainly it's the descriptor. The descriptor is a link local identifier, something like an IF index perhaps. And then we have sub TLVs which describe the attribute of this specific member link. So if there are multiple member links, you'd see more than one instance of this sub TLV under the link TLV. Next one. So there are no new link attribute sub TLVs defined for this particular layer 2 member types. The idea is that we would reuse the existing TLVs that we have for layer 3, just that they would be included under this one, and they would be associated with the L2 bundle member. The draft talks about the ones which are applicable for layer 2, like adjacency SID or the maximum link bandwidth, and then it lists others like addresses and identifiers which are not really applicable for a layer 2 interface. Next one. So this is mainly just OSPF encodings for the draft, which is already ISIS draft, is already RFC editor, but we like to request a review and feedback. Yeah, okay.
So I saw a couple of attributes like adjacency seats and the bandwidth, but I would think that the latency and loss would be also applicable here as well.
Yes, so I didn't list down all the things, but in the draft, yes, they are marked as applicable.
If you look at the draft, you'll see that. And it's kind of funny. The draft says it's not going to, that's out of scope. And then later on, you see that. You might want to remove that to say what things are applicable.
Oh, okay. So maybe there's some. So we were debating one way or the other, but then we have the draft explicitly lists which is applicable and which is not. So I'll go back and correct the text.
The other thing I point out in OSPF, and we can thank the CCAMP working group for this, we have arbitrary level nesting of sub TLVs. So we really only have top level TLVs and sub TLVs that can be nested at arbitrary levels.
Yes.
In some cases. So you said sub TLVs. We shouldn't use the term sub TLVs or sub TLVs or sub TLVs.
Okay. Point. I got the point.
Okay.
Thanks. Next one, please. Oh, are we?
One more week. 7 minutes. You think you can do it?
Yeah,
in
I
7
think.
minutes?
You think you can do another one in 7?
Yeah.
Okay. You don't think anybody's going to get up and want to make a lot of room?
Okay, it depends on which one it is.
Uh-oh. Oh, do you think I need to just click on the next slot?
Can you do maybe the BFD
Yeah.
one? I don't know if I can choose.
D1 would be better than SRBC.
Yeah, that other one. Okay. Yeah, thanks. So this is a follow-on update. This draft was first presented in Prague. about the OSPF working with strict mode BFD. I go to the next one. So quick recap on what the draft does. So it's a mechanism. We're trying to standardize something which many implementations do already, which is want to run BFD to monitor liveness. And at the same time, we do not want to bring up the OSPF adjacency until the BFD session is up. So there is an ISIS RFC which does something similar for ISIS. Go to the next one. So just a very quick reminder how it is done. It's really, we introduced a new B bit flag in the LLS extended options and flags. This is part of the hello messages. And this is how a neighbor, OSPF router can inform its neighbor that it wants to operate in this strict mode. The BFD session is requested right when the new neighbor is detected. So the draft talks about the FSM changes. It's really that the neighbor FSM is held in the init state until the BFD session is up. So we do not ask for, we do not progress the FSM until the BFD session is up. And once the BFD is up, we goes on to the two-way and start stage. So that's in a nutshell the summary, the proposal. Next one. So these are the updates. First thing is we changed the title from OSPF BFD strict mode to OSPF strict mode for BFD. Got a lot of feedback saying that, which correctly said that this is not really a BFD mechanism, it's a OSPF mechanism. And then there was some feedback on the need to indicate that for graceful restart scenarios, because we have this additional BFD establishment thing, we need to indicate that. So the timers need to allow for this, especially in a scaled scenario, perhaps. Tony, you had a question?
Tony P. Just clarification. I mean, what additional functionality do you get compared to a local configuration where you hold down sending hellos until the BFD on your side comes up? Why do you even need this signaling? Confuses me. And we know the problem, right? The problem is absolutely valid, right? You want a local config saying, until I get a BFD up, no SPF. But if you don't send any hellos until your BFD side is up, the other side cannot come up, right? So it doesn't even matter whether both sides are configured. One side configuring doing that is already forcing the behavior.
Yeah.
Maybe
so
for debugging purposes or something, but I just don't see how that adds any additional functionality with all these signaling piled on top.
So OSPF hellos do need to be sent, otherwise you do not detect the neighbor. If you do not detect,
until BFD up session comes up, there's no point in even sending those hellos.
we do not even learn who the neighbor is and who to set up the BFD session until we see the hello.
That also does the setup of the session. Okay, so
Right.
that's the BFD signaling part. Okay,
Yes,
got it.
yes, yes. Okay. Okay, and the last bit, I think we can go to the next slide. So we have OSPF v3 multi address family. So we can have IPv4 instance routing supported by OSPF v3. Now, in this mechanism, what happens is all the hellos are done with link local IPv6 addresses. But because it's for the IPv4 address family, we need the session establishment has to be for the IPv4 neighbor address. And we don't know this when we are operating OSPF v3. So next slide. So there is a new TLV being introduced in for LLS, a new LLS TLV being introduced for OSPF v3, where we propose that the local interface IPv4 address is exchanged in the hello itself. So this way, normally in the OSPF v3 IPv4 working, we would wait for the link LSA to learn the neighbor's IP address that we could install as a next hop in the routing. Here with this TLV, we know it from the first hello. And so this way we can run BFD strict mode for OSPF v3 IPv4 as well. Yeah. So we have received some good feedback, reviews, and interest. So I think it will help to standardize this and I would like to request for working group adoption.
Okay, how many people have read this draft, understand the technology? Okay, yeah, and how many people are in support of adopting it? Yeah, okay, and we'll put that on the list, but it's a good, it looks good.
Who figured out that IPv4 instance?
So we got a mail from a customer who was trying to do this.
Oh, okay.
Yeah,
So,
and
so that's
and we
good.
have the names in the draft.
Okay, so we got two last presentations in the later, which means we have more time to argue about
To discuss.
flow control.
Yes,
Yeah,
yes, yes.
to discuss flow control, receiver side, sender side.
So please come. This means, even though you're done, Peter, you cannot go to the bar yet. It's done presenting. So that one, surprisingly well, because we were preparing for it right up to the last minute.